Hi class, we are doing 17.4. So hopefully you've watched all the videos and done all of the homework for 17.1 through 17.3 on our similar triangle unit. This is the last section for our similar triangles. So 17.4. Just as a recap, remember that triangles are similar. I'm going to move this up so we have a little bit more space here. Triangles are similar when they have congruent angles and proportional sides. So what we mean by that is if I have an angle measure in one triangle, I have the same angle measure for a corresponding angle in the other triangle. And in all three cases, the same thing happens. So three angles, corresponding angles of another triangle are exactly the same measure as the first three. The ratio on the sides is the same. If I have 3, 4, and 5, and I have a multiplier of 2, so this side's 6, this side would be 8, and this side would be 10, because I would have to make sure that it is 1 to 2, 1/2, as a ratio for all three sides. Just has to be that way. That's how we get similar triangles. Now, the next part is proofs. Sorry about that. We're going to be doing, we already did some proofs. We're going to be doing a bit more today. And the proofs, we already know the three triangle proofs that prove triangles are similar, like angle similarity, side similarity, and side angle side similarity are the three shortcut methods for proving two triangles are similar. What we're going to be doing today is moving on from that a little bit more and using that, and then also using something else. We're going to talk about two different things that are very similar to CPCTC, which meant that if I have two congruent triangles, with those two congruent triangles, corresponding parts are always congruent, or if the triangles are congruent, then the corresponding parts are congruent. So the same thing goes with these similar triangles. CASTC stands for corresponding angles. I don't know why it's moving down today. It's been driving me crazy all morning. Corresponding angles of similar triangles are congruent. So if I know that triangles are similar, then for sure their corresponding angles will be congruent. So this is going beyond the similar triangle proof, just like congruent triangles in the CPCTC says that congruent triangles have corresponding parts that are congruent, and so you prove the triangles are congruent first, and then you use CPCTC to show that parts are congruent. That's going to be the same thing as CASCT is for similar triangles, in that once you've proven the triangles are similar, then you can use CASTC to prove angles in the similar triangles are congruent, as long as they're the corresponding ones. Okay? Same thing with CSSTP. We have to have two because unlike in congruent triangles, we have sides that are not congruent, but they have the same proportion, or they grow at the same rate. So CSSTP is concerning the sides. So you notice this little letter there. Corresponding sides of similar triangles are proportional. All right, so that's what we're dealing with. So corresponding angles of similar triangles are congruent, and corresponding sides of similar triangles are proportional. So those are just the basic properties that belong to similar triangles, and we have two different proofs or theorems in order to help us prove that those parts are proportional, or that angles are congruent, after we've proven sides, or that two triangles are similar. So let me get my eraser out. Erase all this. What we're going to be doing on the proofs then is first proving the triangles are similar using those properties or theorems that I just erased. We're going to prove that they're congruent using AA similarity, side similarity, or SAS similarity. And then once we've done that, then later on our proofs are going to have us go one step further and state that a certain pair of corresponding angles are congruent, or corresponding sides are proportional, whichever is asked for. So here we have two triangles that are overlapping triangles. So as you know, I like to outline these. I wish I had a better way, but I don't. So that's one triangle. You can write it out here if you'd like, if it helps, EFG. And then we have a larger triangle here, and that's DFH. All right, so these two triangles have the same angle F. It's an overlapping angle. You note that it's going to be congruent. And then we're also given the information that EG is parallel to DH. Now, if EG is parallel to DH, then that means we have another angle, the corresponding angle, and actually all three are going to be congruent because we have corresponding angles in both sides of the triangle, the similar triangle. So what that says is these angles are congruent, and we therefore have similar by angle-angle similarity, right? So I don't know which one you want to look at, the overlapping original or the two that I have separated, but whatever the case, we have enough information to show that these two triangles are similar by angle-angle similarity. So in order to do our proof, I'm going to move up a little bit, but not too far because I want to be able to use my information. So our given is that EG is parallel to DH, so hopefully you've already got that filled out because I'm a little slow. That's given. And then angle D, so that's this angle right here, or here, is congruent to angle FEG. That's this angle here. All right, so that is a corresponding angle based on the parallel sides, and that we would say is because they're corresponding angles. Sometimes I like to write theorem there. And then the reflexive property, we're going to state that by the reflexive property of congruence, that angle, those are the top angles, F is it? Yeah, angle F is congruent to angle F. So those are overlapping or corresponding angles. Angle F is congruent to angle F by the reflexive property, and then the two triangles are similar by angle-angle similarity. Okay? So we can state that triangles are, or prove that triangles are similar based on those three properties, angle-angle similarity, side-side-side similarity, and side-angle-side similarity. All right, our next proof, we're given that WY over BC is equal to WX over AC is equal to over AC is equal to WX over AB. So those ratios of the sides are congruent, which means our sides are proportional. So whatever WX over BC is, that ratio is going to be the same as YX over AC is same as WX over AB. So these are going to be proportional by side-side-side similarity because it tells us right in the given that all the sides are proportional, which is one of our shortcut proofs. So we can say as our statement, WY over BC is equal to YX over AC is equal to WX over AB, and that's our given. And that basically says all the sides are proportional, and because all the sides are proportional, triangle WXY is similar to triangle BAC by side-side-side similarity. And what we're asked to prove are these two corresponding angles, angle W and angle B, are congruent. Now, because the triangles are similar, they're congruent because that's a property of similar triangles, and therefore their angles, we're going to use our corresponding angles of similar triangles are congruent. So cast C there, because we were trying to prove that two angles that are corresponding in similar triangles are congruent, and we prove that by using the similar triangle property, and those properties state angles are congruent. All right, I'm going to move down a little bit. I know we've done 2, which are pretty easy. I have about 5 more minutes. I'm going to do one more, number 5, and then let you work on the rest of the assignment. So we're given that AC, side AC, is similar to AE, and angle CBD is congruent to angle EFD, and we're asked to prove that triangle BCD is similar to triangle FED. Now, there are a lot of triangles going on here. We have some auxiliary lines that are creating a few triangles that are a little bit difficult to spot or determine which triangles are we talking about, because there's so many. So if there are so many, then let's just really quickly mark which two triangles we're trying to prove are similar. BCD is this triangle, and then FED is this triangle. So those are the two triangles we're actually trying to prove congruent. What we've been given is that AC is congruent to AE. So that's this side is congruent to this side. And those are sides of the big triangle. That means this triangle is an isosceles triangle. What do we know about isosceles triangles? Well, if it's an isosceles triangle, then these base angles are congruent. So that gives us a congruent angle in the triangle. Okay. We also know that angle CBD, which is right here, is congruent to angle EFD, which is right there. So you have two congruent angles in those triangles, and therefore they are similar by angle-angle similarity. So that's going to be pretty easy, actually. So we're first going to state that AC, side AC, is congruent to side AE, which is given, and that information gave us the two congruent angles, angle C and angle E. Now they're congruent because they are base angles of an isosceles triangle. All right, that moved on me, so hopefully you can still read it. Then, because those are base angles and you're congruent, we also have angle CBD is congruent to angle EFD, and that was given. And the triangles are congruent by angle-angle similarity. Okay. Looks like we have time for one more. Let's try one of these. So number 6 is the one I want to do. We're given that LQ is parallel to NP. So I'm going to mark those with blue, like usual. LQ is parallel to NP. Okay, I'm going to mark with the angle or the arrow so we know those are parallel. And then what that tells us is alternate interior angles are congruent. Okay, and we have two sets, and that's what we could use. We could also use our vertical angles, but I'm going to just state that LQ is parallel to NP, and that's given. And with that information, we got angle Q congruent to angle N, and angle L congruent to angle P, and that is by the fact that they're alternate interior angles. Having a hard time writing on this. All right, and because I have two sets of congruent angles, then they are similar by triangle LMQ is similar to triangle PMN by angle-angle similarity. All right, so you can go through and, gosh, I want to do number 7. I have 1 minute. Let's see if we can do it. So we have this side over this side is same ratio as this side over that side, and we have this angle H that's congruent because it's similar. We're asked to prove that angle K is congruent to GJH. Those are corresponding angles. So we have overlapping triangles. We know they're similar because of side angle side similarity. We have our side and then an angle, then a side. So we can state that, and then by CASI, we can state that the angles that are similar are similar. I'm going to just hurry and write this out because I'm kind of out of time. JH over KH is given. And then 2, angle H is congruent to angle H by the reflexive property of congruence. And then we know triangle GJH is similar to triangle FHK. Oh, FKH, sorry. FKH, dang it, that's going to cost me some time. FKH, and that's by angle-angle similarity. Oh, no, wait, it's side-angle-side similarity, right? And then 4, angle K is congruent to angle GJH by CASI. All right, I'm going to quickly stop it because it's at 14:55. Let me get my arrow over here. Okay, good luck.